Hello and welcome back to the channel. Thanks for looking in again. So today, what are we going to talk about? Well, we're back to track and we're looking at R.492 and R.493 Super 4 diamond crossings or crossovers. Now, these things can cause a lot of problems on the layout. Now they're getting older. There's many areas where all these rails cross over and current is transmitted through these small pieces of brass. Where they're riveted, it's not such a problem, but at the ends they're just looped over the plastic base and the track just sits on top of them. There's a little bit of tension, but they tarnish quite easily, and I can show you about that because this one has got a bit of rail missing here, and if I bring this up to the camera you can perhaps just see the little bit of brass in there, and that's tarnished quite heavily. Now, over a period of years you get resistance in these and they can really affect the running of the layout. Now I want to clean up mine, which are all in similar conditions. Not brilliant, I haven't got any better than this, I don't think. So I'm going to have to find a way of taking them apart. I'm going to replate the steel rails, clean the alloy bits, and then put it all back together. So in this video we're going to cover stripping down these crossovers. So I'll get this on the bench, gather a few tools together, and we'll make a start. Right, so we're going to start taking this apart, virtually in a similar way to what we did with the Super 4 points in an earlier video. I'll try and see whether I can point out some of the fish plates and odds and ends have got little tabs, and what we have to do is we don't want any damage to the sleeper base, so we don't apply any upward pressure to the rail, because if we apply upward pressure to the rail it will crack the little lugs. So I'm using this special pair of pliers, just ground the ends down a bit, just to grab and start making sure that I can move these rails over the plastic retainer. And there comes the first one. So I'll just pull that out, very rusty. And then if we look, should be able to see where it makes contact with the brass, which is just there, and it's extremely tarnished. So if I use this little screwdriver, I bet I can just clean that a little bit so you can really see that there is indeed a piece of brass there. So I mean, that amount of corrosion is going to cause all sorts of issues with conductivity. But there we are. I think you can probably now see that brass pad. And the underside of the rail is very tarnished as well. Okay, so we'll move on to the next one. So we've got another one here. Just ease the keeping plenty of pressure to avoid it being forced up. And out comes the next one. Now the brass on this one is actually a little bit cleaner, so that wouldn't have been causing so much of a problem. Okay, I'll continue to get these out, and once I've got all the steel out we'll come back and have a look at starting to remove these conductors from the underneath. Okay, that's all the steel bits out, and you'll be left with 3 pairs of steel rails. Just to show you the sort of tabs that we're talking about on the bottom of the fish plate, just there where my nail goes. they are what locate these, so we're bending them up slightly to clear the plastic. Take plenty of photos first if you're doing this, and then you won't get mixed up later. These two haven't really got fish plates, they've just got a welded on tab an inch down the rail. So it's very critical not to break these. Okay, so let's get on to the underneath. So the baby rivets, the small rivets, we're going to take those off with a drill. So firstly, I've got a little spring-loaded punch. Just going to centralise those two rivets. And then hopefully my drill will stay central when I go to drill. Just want to take enough off the rivet head to allow the piece of brass to come over the top. So I'll just take a little bit more off there. Oops, just slit there. Now this is critical to take a bit more time than I'm doing. This alloy is actually harder than it looks. Now avoid putting too much pressure. Just let the drill do the work. Right, I think we're about there now. So I'm just going to see whether I can ease this. It's very thin. Now you see the brass has come free from the rivet head. And then we've just got to very carefully bend up the tabs a little bit, and then we can ease it out. So here is your piece of brass. A tab at each end. Now we don't want to break those, so we're not going to bend those anymore, we'll just clean them. And then the riveted area in the middle. So we'll just deal with this other one now. Try and drill a little bit more carefully. Just going to let the drill do the work. Yep, it's going nicely. Just need to remove a minimum of material. I think that's ready to ease out now. I'll just get my little screwdriver underneath, pop it off, just fold up the tabs just a little bit. We should be able to remove it. Okay. Now that leaves us with the insulation layer. So I'm going to ease this up now and we should see what's underneath it. Very carefully, because we don't want to damage this, because we should be using it all again. Okay. Again, just taking some photos as you disassemble is really helpful. So we've got the same again under there. Now that tab was actually not making contact. I haven't drilled that rivet out there. That was actually loose. So we already found a fault there. This one is tighter. Okay, I've got 1, 2, that one was already undone. 3 more, so I'll just centre those and drill them off camera and get those off, and then we'll come back and look at the alloy parts. Fine, right, I've got these drilled out now. Now we've got to start being very careful because there are some smaller pieces that will dislodge that I will show you shortly. So I've got the ends of those released. You can see the plastic base now with just the rivet heads of the alloy parts. Now if I turn it back over, I just want to draw your attention to where the short rails were. Now there's actually some more pads that fit by each of the two alloy short rails and each of the two steel short rails. Now these little pads, I forgot to mention, are freed up once the rail has been removed. Now I don't know whether you can see this small pad, but I'm going to put it back into its position. I've cleaned it a bit so that you can see. So these pads just give extra contact. They should spring up in an ideal world and touch the actual base of the wheel to carry a little bit more current conductivity further along as you go, because the gap is quite large between, say, there and there. But when you look at the gap with the small spring in place, you've actually got current ends at that rail there, but continues on the underneath of the wheel to there. So anyway, these small things are released when the small pieces of rail are removed. So it's very important not to lose them. Right now, I'm going to see whether I can start removing some of these alloy pieces. So I'm going to put this down on the bench and using a small pair of pliers, hopefully I should be able to pull them out of the plastic base. Just going to be careful. Let's try and work this up a bit at a time. There's the first one. Now I hadn't quite drilled the rivet head right off, so that's what was making it difficult to remove, but that can be tidied up later. So there's the first small one. So I'll try the small one at this end now. So I'll just gently, I think this one will come out a little easier. You can see that I've got the rivet head somewhat better. These are very dirty, these pieces of alloy. They'll really need a good clean. Now I've got those out, there should be two more of the little steel pads. So we can just lift those out, the sprung steel. There's the first one. I'm going to put my thumb over that and see if I can tip that one out. There's one. And then the second one there. So I'll put those safe. So all we're left with now is the plastic base and these four pieces of alloy. So I'll see if I can just pull those out now. Just check where the rivets are, right in the centre. So I've got one. That's a bit tough. Let's try this one. Two. 3, and then we'll come back to this difficult one. Let's just have a look underneath. That one doesn't want to move at all. Just going to give that a little go with the drill. Yeah. So we now have the whole of the crossover stripped down. So what have we got? We've got 4 central segments of alloy, 2 small alloy rails. We've got all the brass from underneath, the insulators, 6 steel rails and 4 pads. Now there's only 3 there because there was one missing on this, and I've borrowed a steel rail from another crossing here, so I can actually take out the small piece of steel there to make 4. So once again, we've got plastic base, 6 pieces of alloy just there, insulator with 2 further pieces, the 2 underneath pieces of brass, 2 short steel rails, 4 further steel rails, the 4 pads and the 2 other brass conductors. So there's a lot of parts in these, but we have got it apart. But that's not the end of the story, because of course to get it back together we've got to find a way of fixing it. And as I say, all these pieces of alloy have got these small rivets. So the next thing I'm going to do to finish this video is I'm going to demonstrate how I'm going to remove this lug and put a fastening in. So I'm going to put this all away, tidy it into a container, and then I'm going to show you how I attempt to remove this and put a threaded boss into there. Okay, well here we are at the vise. Now I just thought I'd draw a couple of things to your attention as we get going. Here's one of the 4 inner pieces. I'm just going to snap the rivet off. I'm not going to attempt to file it down. It just breaks off and leaves a really, really nice mark where the centre of the drilling has got to happen. So rather than filing it down, if we snap them off, they break off nearly flush, hope you can see that, and leave a really nice, well, it's not an indentation, but it's a place so we can start to drill. So what I'm going to do is I'm going to put this in the vise. Now I haven't got the soft jaws in at the moment, I've just got some very thick tape there to protect it. So because I've got that mark there now, I should, in theory, be able to get a good centre punch into that. Now it's soft. Now that went beautifully that time. So I'm quite happy with that. Now I know a few of you are probably thinking you don't like the way I use the drill with my fingers so near to the bit. Health and safety is always important, so please drill the way you want to drill. It's just that I often use my finger when I'm putting minimal pressure on the drill just to guide the tip into place. Now obviously if I was to press down hard and break that drill bit, then I would probably injure my finger, but I've been drilling for a long time, many years, and I've just learned my particular way. And this is a 0.8mm bit, so I'm using quite small drill bits. I mean, I do have some that go right down to 0.3mm for some of the clock repairing jobs, some of the smaller repairs. But I'm going to initially drill this out 0.8mm. So, just using my finger to guide the tip of the drill, and then very gently starting. I'm going to use, now I'm not using a pillar drill, I'm obviously doing this freehand, so I need to get this as level as possible, so I'm going to just do this by eye. Now it is quite soft, this alloy, so we're already getting a good start there. And we'll start again. And when I say let the drill do the work, I mean exactly that. The weight of this quite large cordless drill is enough to let the small 0.8mm bit bite in quite nicely. I'm just going to take this out and see how we're doing. Well, that has gone very nicely. Now I'll use another drill bit just to see how the depth's going. So we've got we're going in that quite nicely now, and also quite centrally. So I'm going to drill that out a little bit deeper now. Okay, now I don't want to drill all the way through, so I'm just going to have another little look, see how we're doing depth-wise. Getting down quite nicely there. Now I have gone slightly off course, so I'm going to bring that back. Partly rushing to film. Okay, let's just have a little look. That's centralised. Yeah, that's nice. So we've now gone in. So if I can get my thumbnail, we've drilled into there probably about 3 millimeters, and we haven't affected the integrity, the structure of it at all. Right, so I guess the next thing to do is to decide what size thread we're going to do that. So I'll just go and get some other equipment, and we'll be back to look at the threading in a minute. Okay, so I've been hunting round, and here's some screws that I'm settling for. So I normally work in BA, not mil, for the smaller repairs, and these are 12 BA screws, quite fine, but they are about the same diameter as the original rivet post, and they fit nicely through those brass connectors holes. So if I'm going to tap this for 12 BA, I'm going to need a slightly larger hole than 0.8. So I've just put a 1 mil bit in my drill, and I'm just going to enlarge my 0.8 mil hole to a mil. There we are. Okay, so here is my tap. So this is a 12 BA tap, and it's extremely fine. It's a tapered tap, so it won't thread all the way to the bottom of the hole. I can always follow this down with a blind tap once I've started, but we'll see how we go. So I don't put any attachment to the top because it's so easy to break these. I'm just going to use finger and thumb pressure. So I'm just going to line it up with the hole I've drilled, and you can see it's just starting to go in there, and then I'm just going to rotate forward slightly, backwards and forwards, and just start cutting the thread. I go backwards just to release the tap. Don't try and do it all in one move. Take it out and just tap the swarf away. You could use a little bit of oil on it if you want, but I think I'm going to cut this dry. Gives me more of a feel of how it's going. So I'm starting to get in there quite nicely now. So I think that's nearly hit the bottom. Okay. If you look at this piece of alloy, there's no sign of any change to the outer edge because we've drilled down very accurately into the middle. Anyway, let's get our 12BA and see whether it's screw and see whether it'll go in. And there we go, right from the start. Beautiful. So I'll just get my screwdriver. I mean, really, it doesn't need to go in terribly far, as long as it's gone in a few turns. But that's, I mean, you can see that's gone in nearly half a dozen turns. So that won't strip the threads, and that will give us a really nice... Right, let's find a shorter screw then. See if we've got one down here anywhere. It's a little bit fiddly on camera, so I'm sorry about that. Here we go. I'm trying to hold it so you can see the screw actually going into the alloy. Oops. There we go. It's gone in a couple of turns now. Just guide the screw in like that. And you can see now that that's going in nicely. Now the screw needs to be obviously long enough to cope with the thickness of the plastic base as well. So hopefully that'll be about the right length. So let's go for a trial fit. So I'll just undo the screw. I do not want to drop it on the floor because I dare say I won't find it in here. Right, so that goes there. They are handed. There's two with left hand and two with right hand ends. Lines up beautifully with the hole underneath. So we'll just get one of the pieces of brass. We're not going to fit it right in. Pop it over. Get our screw. And then just tighten it up. Just find the threads. We don't want to cross thread. It's going in really nicely. Yeah. So, I hope you can see on the camera that we've got the alloy bit in exactly the right position. Underneath, we've got our contact, and in place of the old original rivet, we've got our little screw. Now, I know the head is somewhat higher than the rivet, but we can overcome that either by dremeling or I don't know. We'll wait until I rebuild and see how much we need to take off, if any. So for now we've overcome the actual breaking or drilling off of these original fixings. We've made a really good strong threaded repair, probably better than the original rivet. We've got a nice tight screw in there, so we've got good continuity. And more importantly, from this angle you can't tell anything's happened to it. Now I will point out that the smaller rails are a little bit narrower, the smaller alloy rails. So I don't think I'm going to do those with 12BA. I think we will actually use the 14 on those. Now I'm not going to do them now, but I will just show you that if I take the pliers, just move this, grab the rivet, see if it breaks off in the same way. It does indeed. Breaks off really cleanly and gives us a fantastic indication as to where to drill. And I will drill that exactly the same, but rather than 0.8 I will probably start off at 0.6 and then thread that, because it is narrower, with 14BA screws, and I will show you some of those just to give you an idea of what size they are. Just bear with me while I find some. They are incredibly tiny. Here we go. So I don't know whether you can see that on the vise there, but that is a 14BA screw. If the head of the screw is not big enough to clamp the brass, it doesn't quite pass through, but it's not ideal, I will put a small washer onto that. So for the other smaller rails, we're just going to do exactly the same procedure with the slightly smaller screw. So we'll have 4 12BA screws in these 4 internal pieces of aluminium, and then the 2 other smaller pieces of aluminium which go there and there will use the 14BA. But this is going to mean that the whole thing will screw together tightly and we'll be able to make a very good repair. So hopefully in next week's video I'll get the cleaning up done, I'll get the plating done, and unlike the points where I didn't do a video of the reassembly, because this is slightly more intricate, I think next week we'll show these being reassembled and then get them on the test layout and run a few locos over them and see if they perform, okay. I'm sure they will. But we'll do a couple of tests as well. So I appreciate you looking at this. I'm sorry if it's a little bit long-winded, but they are quite a difficult piece of track and very difficult to find in good condition these days. So I think this will be a good way to utilise any that look quite tired or have bad connections in. So thanks for watching. I'll see you next week, and goodbye.